In this lesson, we're going to be talking about solving quadratic equations using the square root property. So this is our second method. The first method was solving by factoring. In these examples, we won't be able to readily factor them. Even when using the square root property, there's two different situations where it would be best to use the square root property. What we have here would be when we don't have a middle term, bx, when we're given ax squared plus bx plus c equals 0. Essentially, we only have one x, and that x is being squared. So if you have something that's squared, we cannot factor it because we have a sum of two squares, not a difference of two squares. So in order to solve this using the square root property when it's in this form, first we want to isolate that x squared, so get the x squared by itself. So what that means is that I'm going to move over the 25. So when I move it over, I'm going to be left with 9x squared equals negative 25. Continuing to isolate the x squared, I would need to divide both sides by 9, which means we would be left with x squared equals negative 25 over 9. At this point then, our next step would be, in order to solve for x, I would have to take the square root of both sides. So when we have that, I'll rewrite the original, or rewrite what we're up to right now. We have x squared equals negative 25 over 9. So in order to get x by itself, in order to undo a square, I would take the square root of both sides. Now what's important to remember is what we talked about back in section P.2, that the square root of x squared is actually defined as the absolute value of x. So I have the absolute value of x is equal to the square root of negative 25 over 9. Well, why this is important is because we actually have more than one solution. The absolute value of x is saying that we're going to equal the square root of negative 25 over 9. Well, inside the absolute value, that x can either be positive or negative. So I can say that the absolute value of x rewritten would just be x equal to a plus or minus square root of negative 25 over 9. So previously you might have seen people just kind of skip that middle step of the absolute value, but it's important to understand where this comes from, is that we're taking the square root of both sides, but we need to understand the square root of x squared is the absolute value of x. So the absolute value of x is equal to the square root of negative 25 over 9. And then since the absolute value of x will equal positive when the inside is either positive or negative, that's why we can make the jump to say that x is equal to plus or minus square root of negative 25 over 9. Because remember, when we're squaring a number, whether it's negative or positive, the answer will be positive. Our last step then would just be to simplify. So if I have then x equals that plus or minus the square root of negative 25, a negative under the radical means we're going to have an I. Square root of 25 would just be 5, and the square root of 9 would be 3. So we would have an answer of x equals plus or minus 5/3 I, or if we want to write this as a solution set, we would say that we have 5/3 I and then negative 5/3 I. The next situation where it will be advantageous to use the square root property is when we see that we have a quantity squared. Although you can technically multiply this out and use another method, if we can see that we have a quantity squared, again, it would just be best to use that square root property. So this would be our second situation where we have something, a quantity squared, versus the first situation where we just had an x or some variable squared. So our first term here, similar to what we just did before, is that we want to isolate the quantity squared. So that means I need to move over the 3. Well, the 3 is being multiplied, so that means I'm going to have to divide both sides by 3, which means that we are just left with x plus 2 squared equals to 12. Now, just like what we had before, in order to solve for x completely, we would need to take the square root of both sides. So I'm going to rewrite what we have right now, which would just be x plus 2 squared equals 12. So I'm taking the square root, but again, when I'm taking the square root of an x squared, this really means that I have the absolute value of x plus 2 equals the square root of 12. But again, that inside can either be plus or minus to get us that answer of square root of 12. So I'm going to look at this then as x plus 2 equals plus or minus square root of 12. Whenever we have a square root, we do want to try to simplify it. So once we're simplifying here, square root of 12, I'll come up top, square root of 12, your largest perfect square factor would be 4. So you'd have square root of 4 is square root of 3, and then the square root of 4 is 2. So we actually have x plus 2 equals plus or minus 2 square root of 3. You need to simplify the square root of 12 at some point. You can do it now, you can do it at the end. It's completely up to you. Last, we just want to completely solve for x. So in our example 1, once we took the square root of both sides, we were solved for x. But for here, since we had that quantity squared, we have a little bit more work to do. I'm going to need to move that 2 over. So that way we have x equals negative 2 plus or minus 2 square root of 3. And remember, these are not like terms. If we're writing this as a solution set, we're going to have negative 2 plus 2 square root of 3, and then negative 2 minus 2 square root of 3. So our square root property is beneficial if we have a quantity squared, or if we are missing that middle bx term and we just have an x squared.